In this video, we will understand how sky looks blue and our sunset is red and our cloud is white. So we know that the sky is blue because the air molecules selectively scattered the short wavelength of the visible light. These short wave are green, violet, blue waves, and more effectively that we have longer wavelength such as red, orange, and yellow. When this shorter wave reach our eye, our brain somehow process them and something like the color blue. So therefore, on a clear day, when we look up, blue skies strike our eyes from all directions that light is scattered, make the sky appear blue. Well, let's talk about at noon situation. At noon, the sun is perceived as white because all the wavelength of the visible sunlight strike our eye. At sunrise and the sunset, the white light from the sun must pass through a thick portion of the atmosphere. Scattering of the light by air molecules or air particles, those removes the shorter wave blue light from the beam and leave the longer wavelength of red, orange, and yellow to pass through the air. This situation often creates the image of a red sun in sunrise and sunset. An observer of a sunrise and sunset, you can understand that at the dawn, if you look at. Now, the sky is blue, but why? The clouds are white. The cloud droplets are much larger than the air molecules, so the cloud droplets do not selectively scatter sunlight. So instead, what that does, these larger droplets scatter all wavelengths of the visible light more or less equally. Therefore, the cloud appear white because millions of cloud droplets scatter at the wavelength of the visible light about equally in all directions. So, in a nutshell, if we would like to understand that, the red, orange, and yellow, they have longer wavelength, and this means they scatter less amount of during the pass through the atmosphere. The green, violet, and blue shorter wavelength scatter much. So this is the situation. That's why this green, blue, and violet is scattered much. That's why we see the blue sky. Red is scattered less, because that's why at the sunset and the sunrise we get red, orange, and yellow mixed types of view of our sun. And here the sun at noon, that passing through a shorter path into the atmosphere, that's why the scatteredness are minimum for red, for blue. That's why we'll see all visible light as a white. When sunset or sunrise, this is actually penetrating through a longer path into the atmosphere. So the blue light already been scattered and only the red, yellow, and orange light can pass through to reach out our eye. That's why we see sunset and sunrise is red.